Hi students, today we are going to learn about short circuit test. In the previous video we have learned about open circuit test. So today we are going to see about short circuit test or impedance test. It is also known as impedance test. Okay. So short circuit test, it is used to find the copper loss, and also it is used to find the equivalent circuit constant, that is R01 or R02, X01 or X02, that is reactance, and impedance Z01 or Z02. R01, X01 and Z01 are referred to primary, and R02, X02 and Z02 are referred to secondary. Okay, and this is the circuit diagram for short circuit test. Okay, so short circuit test means we have to keep the secondary side shorted. Okay, one side is supply is given and the other side will be shorted. Okay, so here we are giving the AC supply. This is phase and this is neutral, and this is auto transformer. This will be variac, and this auto transformer is connected to ammeter and voltmeter, and this is wattmeter used to find the power, and this is single phase transformer and one end is shorted. Okay, so here when we are varying the auto transformer, we can set the current in ammeter. For example, if you are taking 1 kVA transformer, if you are taking 1 kVA transformer and the rated voltage is, we are considering it as 115 and 230 volt. Okay, and here in short circuited, this end will be connected as low voltage, and this side will be connected as high voltage. Okay, so here we are taking the voltages considering the voltages 115 and 230 volt. We are having this formula. See here, V1 I1 equal to V2 I2, which is equal to volt ampere. Okay, so volt ampere, we are taking 1 kilo VA, volt ampere transformer we are considering, right? So here for V1 I1 is equal to volt ampere means, what is the value for volt ampere? 1000, right? That is 1k. 1k means 1000, which is equal to V1 here is 115 into I1. We can find the current I1 here, that is 8.69 ampere. Okay, and then when we are taking V2 I2 is equal to volt ampere, volt ampere is equal to 1000, that is 1k volt ampere, so 1000, which is equal to V2. What is the value for V2? 230 volt. So 230 into I2. What is the value for I2 here? We will get as 4.34. Okay, so here we are connecting the high voltage, right? So we are giving 230 voltage. High voltage will be given here. So this side we are having the 230 voltage. When we are having 230 voltage here, the current I2 is what? 4.34 ampere. Okay, so we have to set the current to 4.34 in ammeter. Okay, we have to set the current as 4.34. How we can set the value 4.34 in ammeter? By varying this auto transformer. Okay, so here by varying this auto transformer, the current will be set as 4.34. This is just for an example. Okay, so when we are setting this ammeter value, we can get the voltage value in voltmeter and power value in wattmeter. Okay, so here when we are giving the AC supply, initially the auto transformer will be in very low value. Okay, by varying this auto transformer, we can set the ammeter value. By setting the ammeter value, particular rated ammeter value, we can get the voltmeter value and the wattmeter value, that is power value. Okay, so here when we are setting this ammeter current value, the voltage here will be very low. So here we are having core loss, and in wattmeter we can get the copper loss. Okay, so here when we are setting this current value, the voltage value will be very low. So this core loss will be negligible. Okay, we can neglect this voltage value and we can consider only the copper loss. Okay, by using the wattmeter, by getting the power value, we can get the copper loss value. Okay, so here VSC in voltmeter, that is short circuit voltage, and ISC is short circuit current, and WSC is short circuit power. Okay, and then uh, from this we can find the equivalent circuit constant. Okay, first we have to find the power value. What is power here in wattmeter? We are considering it as WSC, which is equal to B into W is equal to, we know the formula, V into I cos phi. Okay, so instead of V we have VSC, instead of I we are having ISC and cos phi SC for short circuit. Okay, so WSC is equal to VSC into ISC cos phi SC. Okay, for copper loss we are having only copper loss, so for copper loss we know the value W is equal to I square R, right? So W, instead of W we are writing WSC, which is equal to, instead of I square we are writing ISC square, and for resistance here the resistance value is R naught 1, equivalent resistance value R naught 1. Okay, and from this equation we can find the resistance value, that is R naught 1 is equal to WSC divided by ISC square. Okay, then we can find the impedance value. Impedance value Z01 is equal to, we are having, according to Ohm's law, R is equal to V by I, right? Same like impedance Z01 is equal to VSC divided by ISC. Okay, instead of V we are writing VSC, instead of I we are writing ISC in short circuit format. Okay, so here next reactance, how to find the reactance X01? We have to find the reactance value X01. We are having the impedance Z square is equal to R square plus X square, we all know that. So here from this we can get the reactance value, X square is equal to Z square minus R square. Okay, so therefore X is equal to root of Z square minus R square. Instead of Z, what we have to write? Z01. Instead of R we have to write R01. Okay, so therefore reactance X01 is equal to root of Z01 square minus R01 square. Okay, so here from this equation R01 is resistance referred to primary, X01 is reactance referred to primary, and Z01 impedance referred to primary. Okay, so here we are finding only the equivalent resistance value referred to primary. Okay, if we are finding R0 to X0 to Z0 to means it is the resistance, reactance, impedance value which are referred to secondary. Okay, so these are the equivalent resistance value for short circuit test. Hope you all understand this video. Thank you.